Hey guys, welcome back to Engineering Hack, where we try to solve engineering problems in a way that's hopefully easy to understand. Today we're looking at the third time at the same system here, but this time the problem statement is different and we're interested in time. All the other instances that we looked at this problem, we were disconsidering time or not interested in it. This time we are. Problem statement reads: the system shown is at rest when a constant 150 Newton force is applied to collar B. So far, nothing new. Neglecting the effect of friction, determine the time at which the velocity of collar B will be 2.5 meters per second to the left and the corresponding tension in the cable. Okay, so this problem statement is a bit different because now they're interested in a time in which the velocity is 2.5. So they're specifying the velocity and they want us to find the time. Well, there are two ways we can go about finding the time. One way is to use the same method we used last time and find the acceleration, which we know is going to be constant because we have a constant force being applied here. And then once we find the acceleration, we can take advantage of the fact that acceleration is just how velocity changes with time. And then we can integrate on both sides. And here I'm going to be integrating from 0 to the unknown time that I'm looking for. And on the right-hand side, I'll be integrating from initial velocity, which is v naught, going to the velocity of 2.5. So once we figured out this acceleration using the same method as on the previous video that I'll link here somewhere, then we can just find this unknown here because we know this is 2.5 and this is 0. But the other way to go about this, and this is the way we're going to do it today, is, which is fairly similar, is to take advantage of the fact that we know that force equals mass times acceleration, Newton's second law, and that we know that acceleration is just how the velocity changes with time. So if we combine these two equations, we can come up with the idea that the force times the time, or let's put dt to be more precise, is just this mass times how the velocity changes with time, right? So all I'm doing here is I'm substituting dv dt over here, and then I'm stating dt multiplying to the other side. So we end up with this relationship here. It says the force times dt equals mass dv, which is where we get our definitions from impact and for the conservation of momentum that we'll be applying in the future. All right, so let's use this and find the time and the tension. Well, same thing as on the previous video, I'm going to create two axis systems here. I'm going to say that once again, downwards is positive, even though I know this guy is going to go upwards because we did this so many times. And I'm going to say leftwards is positive. Reason why I'm choosing these directions here is because when we do, our vectors, that is the vector that leaves my axis systems and goes to A, and the one that leaves my axis system and goes to, where's my axis system? Here it is, and goes to B, I find it intuitive for the directions in which the arrows are going to be the positive directions. That's why I choose it this way, okay? And then obviously we expect to find the velocity of A to be negative because we know A is going to be going upwards on this direction here as opposed to the direction of the vector, okay? So what we're going to do is, once again, free body diagrams. We did this in the past, so let's do it quickly now. So because you guys learned how to do this before and you're very good at doing it now. Ooh, here's fine. Okay, for A, for B. For B, we have two of the tensions pulling it like so. We have the force of 150 newtons pulling it like so. Upwards here we have one of the tension, and downwards we have the weight of A. And what I'm going to write now is the Newton's second law for this guy. The leftwards being the positive direction is going to give me this relationship here. That's to be equal to mass times acceleration of B here. Okay, and for this guy, same thing, right? So because I'm saying that downwards is positive, then that means that my weight of A minus the tension will be the mass of A times the acceleration of A. Right, so now what we can do is, since this is force on both sides and then this is mass times acceleration, I'm going to take advantage of this guy here. And where I have my force, I'm going to multiply that by the time. And where I have my mass, I'm going to multiply that by my velocity. So this is going to be transformed. Let's do it here for this side here. This would be equivalent to these two equations. The force, just the resulting force, I should say, the weight of A minus T times the time. And on the right-hand side, the mass of A times the velocity of A. Here, let's change colors. The force, resulting force, which is 150 minus 2, the tension, times the time, equals mass of b times the velocity of b. Okay, in this case, they are both related because we're interested in, they're just as one velocity, one block moves, the other one block moves, so this time is the same time component for both cases at any given moment. Okay, so what next? Well, we have three unknowns: the tension, the time, four, velocity, three, the velocity a. But velocity a is easy for us, right? Because remember how we do our axis systems, we do it for a reason, is because we want to relate the constant length of this guy here, which says that 2 of my xb plus 1 of my xa is always going to be a constant. So that means that 2 of my velocity b plus my velocity a is 0. And I'm going fast on this because we did this in the past already. So you can check the previous video if you're not sure about this. Cool. So that means that there's a relationship between velocity a and velocity b, which we can take advantage of and use it over here. Right? So that means that my velocity a is just -2 of the velocity b. So this is just mass of minus 2 mass of a times velocity b. Cool, we have everything we need because we're interested at the time in which this guy here is 2.5 meters per second, which is this guy as well. We know this guy is 3 kilograms, we know this guy is 8 kilograms, so there's nothing that we're missing. We have the two equations, the two unknowns, so we can go ahead and solve this, right? So what is this going to, so we can go ahead and have these two equations like so. So the mass of A times gravity minus the tension T will be equal to -15, and then 150 minus 2T times the time will be equal to 20, right? So I'm going to go ahead and speed up and just do the algebra here. All right, so we end up having the tension being 56 point, oh, that's very thick. It's better, 56.77 newtons. And then for the time, all we need to do is obviously apply it over here. And we're going to have that the time. Let's do it in green. The time is just minus 15 divided by 3 times 9.81 minus the 56.77. And this turns out to be 0.5486. So go ahead and approximate that to 49. And that is seconds. Let's check the units quickly. Make sure this makes sense. I have 15 divided by mgt. Where does the 15 come from? That is the right-hand side. So that is mass times velocity. Okay, so that's mass times velocity. So we have mass kilograms times velocity meters per second. And dividing the whole thing, we have 3 mass, and that's kilograms, and acceleration, mass per second squared. So these guys cancel each other out, and then one of these guys cancels this seconds, and then we have the second dividing the division. So we go up here. So we're going to have seconds as our final answer, which is great because that is indeed a unit of time. Cool. So 5.49. All right. So this was, once again, nothing major. We're just applying the same idea as we did on the previous video. I encourage you to solve this problem using the other method if you wish. Obviously, the answer is going to be exactly the same. All you're doing is, instead of converting it to the equivalent here, you're solving this system of equations. You're finding the accelerations, and once you find the accelerations, then you're going to find the time by dividing the difference in velocity by the acceleration that you found. You should find exactly the same things, and obviously when you're finding the system of the accelerations and the tensions, you'll be able to find the tension, right? So I hope this was helpful. If it was, please like the video. If you have any questions, leave them down below, and we'll talk soon.